Hey guys, good evening. Just I'm setting up the things. Let me know if just let me know, guys, if I'm audible. Apologies for a slighter delay here. Uh, okay, I hope I'm pretty much audible here. Okay, guys. Again, apologies for being slight delay today to start the session. But nevertheless, we are pretty much here, and then let's just quickly start the session. Okay, till today we have been discussing. Yesterday we started Pandas, right? And okay, so we are pretty much people bit to Divya, Akash. Thank you so much, guys. Good evening for joining us, and thank you so much. As I said, apologies for slighter delay. I just got stuck in something, and then I got delayed in that. Okay, so today's agenda is Python data frame. So that's what we'll be doing today. So that's pretty much our agenda for the day. But again, yesterday we started with pandas and we started with series. So we discussed about how we do series implementation and then exactly how we create the series element. And we saw multiple ways. So we saw creation of series with the list of elements, and we saw series creation with the dictionary elements, right? So that's pretty much we have already seen. Okay. So that's pretty much part of our things that we covered yesterday. So today we're going to be starting with data frames, right? So that's pretty much our agenda. Hey Hellfire, hey guys, thank you so much. Good evening for joining us. Great. So to start with, I'll just quickly introduce myself and I jump to Pandas data frames. Okay. So as you know, my name is Arpit Jain, and I'm a lead data scientist myself. I have almost 9 years of industry experience into multiple domains, be it manufacturing, automobile, cloud, banking, telecommunication. So any questions regarding any of the domains, I might not be able to answer everything, but still definitely could tackle a few other questions. So please feel free to put up your questions in that area. And also, I'm a motivational speaker, so I take industry sessions. I talk to students regarding their job, career, and all that. So any concerns, anything regarding your job placements, right? So do put up your question. I'll try to answer them to the best of my knowledge. Okay. So that's pretty much about me, guys. Let me jump to pandas quickly. Just give me a minute. Right. So I hope my screen is pretty much visible. Just give me a minute, guys. I'm facing some issues. Yeah. So I hope my screen is visible here, right? Okay. So, what is this, man? Okay. Cool. So pretty much good to start. Okay. So that's what we have. So we were discussing about yesterday. We were discussing about series, right? So in series we did discuss about what? So we discussed about how we can create a series element, and now we have data frames. Okay. So in data frames we majorly talk about two things. So we have two things here. So we have majorly. Just a minute. Why I don't know why this is giving me a trouble. Just give me a minute, guys. I think I'm facing some issues here. Okay. Right. So pretty much good to go. I don't know why my screen is getting stuck. I don't know why. Okay. Anyway, so yeah. So what is data frames? So data frames is nothing but rows and columns, right? So rows and columns, nothing but. So here, just assume that you have a spreadsheet, right? So spreadsheet we have rows and columns. So we have certain set of information or the variables, the data in terms of columns, right? And then we have the rows. So that's what data frame is talking about. It's just like an Excel sheet on Python. So on Pandas, we're going to be calling this as data frame. Okay. So we have the feature of rows and columns. Okay. So again, we saw how to create the how to create a series, right? So likewise, we have option to create the data frames as well. So in data frames, we have the function called as pd.dataframe. So you can see here. So I have pretty much data frames. If I run it, right, you can see once I've run this data frame, I have pretty much the thing which is mentioning like it's a blank data frame, right? Uh, I can just give it. I think there is some issue in my pointer. I'm not able to see that. I think yeah, it should be fine now. Yeah. Okay, now my pointer is available. Okay, so now you can see this. This is my function data frame. Okay, you can see this. This is my function data frame. And here, again, remember this D is capital, F is capital. Okay, so this is how my function looks like in Pandas, data frame. And now, as always, we can always visualize what all different arguments it takes and how we can check that. So just putting my cursor underneath my bracket parenthesis and do a shift tab. Okay. So now once you do a shift tab, you can see the kind of arguments which you can pass here. So we have data, we have index, we have columns, we have d type, and we have copy. So these are my 5 different arguments which can be passed on top of my data frame to create the data frame, right? So again, we need to understand how we are creating the data frames here. So I don't know why this has been an issue. Right. So as you have seen, so we have data, index, and everything, right? So as you know, if you pass the name of my argument directly, so any order is fine, so I can pass data anywhere. And likewise, if we are not passing the name of my argument, then I have to make sure that the order is retained, right? So if I'm not passing the name, so the first argument by default will become what? Will become data, right? So this is something which is very important. So we have to make sure that we are adhering to what we have in this case. So now, the creation of my data frame, we can create the data frame in multiple ways. Okay, so I'm going to show it to you the different ways we can create a data frame. The very first way is to define my data in terms of dictionary. Okay, so the first way is we have to define the data in terms of a dictionary. So you can see this, I'm creating a dictionary here. So this is my dictionary actually. Okay, and in this dictionary I have 2 different key value pairs. The first is my name and the second is my age. Okay, so I'm creating a dictionary element where I have 2 different key value pairs, and you can see this, my key is name and my key is age, right? So I have 2 different key value pairs here. So now you can obviously assume, I mean, it's pretty much evident as well. So if we use name as my key and age as my key, by default, this should be your column headers, right? This should be your column headers, and the data available within these will become your names, the rows, right? So the elements of that column. So for example, here I'm passing in the name, I'm passing Tom, Jerry, Spike, and then some random other names as well. Okay, and likewise I have age, I'm passing the age of all these people. So now what I'm doing is this data frame, so this exact dictionary, I'm passing it over my data frame. And in data frame, we know what all arguments are there. So we have arguments such as data, index, columns, and everything, right? So if I'm not passing anything, any name of my argument, so by default, this becomes your data, right? So this is the first argument is data, right? So this by default becomes your data. So now if you simply run this, we can see it here. So now we have created the data frame in terms of rows and columns, and my columns are 2 columns. So the indexes, the keys will become my column header, my name and age. Okay, and now here in this, the elements of these this key will become the rows, right? So will become the elements of my column. So I have Tom, Jerry, Spike, and all the other things. Okay, so this will become my name. So this will become my elements of my column name, right? And now likewise for age, I have these elements. So I'm passing it over this. So this will become my age. Okay. So this is what pretty much I have in terms of data frame. So data frame is again nothing but your rows and columns. And in this rows and columns, we are creating the first data frame by using a dictionary, right? So here in the dictionary, my key would become my column header, and my values would become my the row elements, right? So that's what I'm creating my data frame, my first data frame, right? First way of creating the data frame. Again, second interesting way of creating the data frame is this. Okay, so we can pass the list of lists. So now here we can also pass the lists of lists. So here in this case, what I'm saying is, so look at this. So I'm creating a list of lists. So I have, this is my parent list, right? And in this parent list, I have 3 elements. All are lists. This is my first sublist, this is my second sublist, and this is my third sublist, right? And I'm passing my elements here. So Tom and 10, Jerry and 12, Spike and 14. So I'm passing basically the elements here, right? So like this, so my rows element, so this will become my first row. So this will become my first row kind of a thing. And the second row, Jerry 12. So I'm passing this as my second row. So I'm passing all the row elements as my list of lists. Okay. Another interesting way of creating the, I would say, the data frame here, right? So here what I'm doing is I'm passing the list of lists in the form of ABC here, right? You can see this, I'm passing here in this ABC, And then I'm also passing some other different arguments here, right? So what are these arguments? Again, just go back to the documentation and see how exactly I'm passing it. So here you can see this. My first argument is data. Since I'm not specifying the name of my argument, so by default, the first argument, this ABC, would become my data. So this will become my data, okay? And now again, I have index. So second column is index. So here I'm also specifying the index. You can see this earlier when we did not specify any index, it just used the default indexing, which is 0, 1, 2, 3, 4, 5, 6, 7. So this is like a default indexing of my Python, right? But now I want the default indexing to not be happening, and I want the indexing to be ABC like this, okay? So this is where I'm giving, also specifying the index of my rows here. So I'm specifying this index as A, B, and C. I can give any index. We have already seen that, right? And also now we have an argument of column. So since we have passed the data, we also need to specify the column names as well, right? So in this case, I'm passing the column names as name and age. Okay. Another way of creating the same data frame. We can use this also. And by doing this, I'll create the similar looking data frame. I have name and age as my column headers. And I have 3 elements here, so which is getting passed under my data argument. And it is a list of lists. Right? It is list of lists which I'm passing it over my data frame. So I'm creating the row elements by this. Okay. Make sense? So this is what we have in terms of data. This is what we have in terms of my data elements. So pretty much it. This is how another second way of creating the data frame. So nothing fancy in this, but just like another way of creating the data frame. Okay. Now I'm gonna show you a few more interesting things. So I've written 3 different examples. Okay. So now look at this. This first example here. Okay, I have a question here from Akash. Can you explain the copy argument? Yes, why not? So just to show you what copy is. First of all, we'll see what copy is. So copy is a Boolean argument, and it has by default is none. So Boolean is means like true and false, right? Whether I want the copy to be created or not. So we'll have a small looking a definition of my copy column. Just look at this. So here it is a Boolean argument. So Boolean or none. So basically nothing but my true and false, right? So here means for dict data, the default of none, like copy is equal to true. So for data frame to do it, the default is copy is equal to false. So we want to create a copy of my argument. We want to create a sub copy of my data frame, and we want to suppose if you want to do some. So this is a data frame, right? And if we want to kind of do some analysis or some feature engineering on top of this df. So this df will get altered, right? But if we keep copy is equal to true, that means that we're gonna save the initial version of data frame as it is, and then we can keep on obviously modifying the additional whatever analysis we do on top of this, right? But we can always keep a copy of it. So like we're gonna restrain the original version of my data frame. So that's what copy helps us. Okay, but again, that's a good question. Again, coming back, so we have another way of writing another different type of data frame. So here, just look at the difference. I want to first show the data and then show you the result. Okay. So now here, what I'm doing is, so just look at this. First, I'm passing a dictionary of elements A and B, and I'm given the values here 1 and 2. So what will happen here in this case? It'll first do this. It'll first execute this A1 and B2. So here A1 and B2. So this one is getting created, right? So in this case, I do not have any C. So the C will not get added here, right? But in the second dictionary, so I'm passing the list of dictionaries now. Okay, so third way of creating my data frame. So I'm passing the list of dictionaries. So in the dictionary, I have single element. So this is my first element, first row, right? And then I'm adding another dictionary where I have another set of elements. So B is 5, A is 5, B is 10. So A is 5 and B is 10 here. And I'm also adding another argument, C is 20. So C is 20 is getting added here, but unfortunately, I do not have anything in the C for my first dictionary, right? So in this case, although C is getting added, but for the first one, the C is not there. So it will be a nan value here. Making sense? So because for the first dictionary, I do not have C, right? So although C is there, so I'm passing the dictionary another key here in the second dictionary. So it has to be added here. But for the dictionary where this key is not present, it still get added, but with the missing value. Okay. So likewise, you can see here again. So I have A, B, and C. So for the first row will be A, B, and C. For the second row will be A, B. So again, for the C, nan will get added. Now I have the third row 1, 2, A, B, C and D. Okay, so now D will be added, and to compensate on D, both for the first row and the second row, NaN will be added, right? Same thing. You can see this. So how this is how, so for the first row and the second row C and D, both will be added as NaN, right? So because this is how I'm passing the list of dictionaries here in form of data. Okay. So again, so you can see this by default we have 0, 1 and 2 as my indexing, right? So by default, because we're not passing any index here, we're just using the data argument, right? But as you know, we can also pass the indexes, so we can pretty much use the indexes. So now in this case, my indexes will become AA, BB and CC, right? So this is what I'm passing this index as AA, BB and CC. Cool, makes sense? Right? So this is pretty much of the topics how to create the data frame. Okay, so this is pretty much how to create the data frame. Now we have very interesting topic of slicing the data frame. So slicing means we might not need the entire data frame to work on, right? So we might need to access a particular section of my data frame to do the analysis, right? So maybe a certain section of row, a certain section of my columns, or maybe in that sense, you know, the entire set or a subset of my rows and columns. So any permutation combination is pretty much possible in terms of my row and column iteration, right? So that is where slicing comes into picture. Slicing means we are now supposed to access a particular row and column combination, okay? And that is through slicing. So data frame slicing is pretty interesting. So till date we have been studying about start, stop and step, right? So giving me the start index, the stop index and the step index, right? But here in data frame we use the concept of lock and iLock. Okay, so we use the concept of LOC lock and iLock ILOC. Okay, this is a very interesting topic and very important topic, guys. So if you're not able to understand this, please stop me and then you can ask your questions. Okay, do not hesitate to ask your question. So again, what is the difference between lock and iLock? Okay, so there are certain major differences. So again, I is always easier to remember. I means integer. Okay, so iLock, integer lock. Okay, lock is simple lock. So iLock, integer lock means we can only give the integers, we can only specify the numbers in terms of slicing. For example, suppose we have, so slicing can be done in what? Slicing can be done either in the row wise, so we can either go to a particular row, or we can also look into a particular column as well. So slicing is possible in both the ways, the rows and the columns, right? But in the columns, I have the names, the name and the age, right? For example, name 1, name 2 likewise, right? Or also we have the indexes. So this is my first index. So 0 index column. This is my first index column. So there's an index also associated with the column, right? So iLock means integer lock. While we are accessing any particular data here, we have to always specify the integer. We cannot specify the name. If we specify the name, iLock will give an error. Okay, because it can only take the integer values of indexing. On the other hand, lock, we can specify both integer as well as label. Okay, and I'll show you the differences also. Don't worry about that, but I'm just giving you the basic definitions as of now. Okay, so as I said, it takes the label as well as integers, while iLock only takes integer. Okay, now here, as I said, list of labels pretty much fine. Okay, and now all of these I'll show you in the differences. So how does it look like? So let me just give you that. So meanwhile, I have a question here from Akash. How does ABC become header? Previously, we saw data as variable like Tom, 10 and data as data argument. So how does ABC become header? ABC become header. ABC to header why nahi na? So you can see this, right? So we have this A and then we have B here and then C here. So I'm passing this A, B and C as my header. Na? So this is my keys. So this is a different example here. So see the here in this one I'm specifying the name. Okay, I'm specifying the name of my column, which is name and age here. Okay, but this is a different problem. So here I'm specifying the key will become my so we know that, right? So here in the first example we saw the key is name and the key is age. So this become your column headers, right? But in this case, in this example, I'm passing A as my key and B as my key. So that is the reason why A, B, C and D will become your column headers. Is it clear, Akash? Akash, do let me know if it is clear. Okay, so looks like I don't know. So okay, cool, great. So let's proceed. So as you know, so we have df lock and df ilock. So we need to understand what is the difference between lock and ilock. Okay, so I'll just give you that. But again, before that, let's try to understand how does it looks like. So we have what? So we have both my row and the columns. Okay. So in lock or ilock, there is a comma in between. Okay. So we have to specify the row condition as well as the column condition. Okay. So both are important. And how are we going to specify that? So the row condition will be a separate filter, and the column condition will be a separate filter, separated by a comma. Okay, so this comma is important. So separated by these two things are separated by a comma here. Okay, so now in this case we are importing this as a pandas, and now we are creating the data frames. How we are creating the data frame? Now you can see this. So we have 4 different column names. Okay, so ONE1 is my first column, TWO is my second column, then 3 and 4. And now I'm creating that, I'm passing the data as my series element. So I'm passing 1, 2, 3, 4, 10, 20, 30, 40 likewise. So this will become my data frame, okay? And now I have created this data, and I'll be seeing this data frame like here. So this is my data frame, okay? This is my beautiful looking data frame. So I have 1, 2, 3 and 4 as my column header like this, and the respective data here, okay? So now on top of this, so as I said, let's take each and every example here, okay? So now, as I said, slicing logic still remains the same. So slicing means we are taking the row index and the column indexes, right? So this is basically what we need here. So row indexes and the column indexes. So here row means 1:3. So suppose what I want here is I want this to be start. So the start and the stop logic will remain the same. So we have discussed about start, stop and step, right? That still is pretty much valid here. But in terms of this, I want to specify both the row and the column definition. So here 1:3, I means like starting from the 1 index, I want till the 3rd index. And also from 1 for the column, I want starting from the 1, I want the 3rd index. So I'm not specifying the name ONE, right? Rather, I'm specifying the indexes 1, 2, 3 and 1 till 3, right? So if I do it like this, for example, now you can see this. Now this is where this thing comes up, okay? So you can see this. If I'm passing over ilock, right? So my m is to n. So whatever range I give, the b it's getting excluded. You can see this, right? So for example, you can see this definition. So here, if I'm passing 1:3, my 3rd index is getting excluded. I'm only getting till what? I'm only getting till 1 and 2, right? I'm not getting actually the 3rd index here. You can see this, right? I'm just getting 1 and 2, right? So this is what this definition says. So if I'm pass it over ilock, the b gets excluded. So that means that the second variable of my indexing gets excluded, okay? And also for 1:3 on the columns, you can see this. So 1 is what? So 1 is my, so this is my 0th index, this is my first index, the 3 is my second index, and FOUR is my 3rd index, right? So I'm passing 1 till 3. So starting from TWO, I want till 4 FOUR, right? So in this case, if I pass it till 3, the 3 will get excluded. So 4 will not get printed. I only get TWO and THREE, right? So this is exactly what ilock does. You got it? This is exactly what ilock does. So I'll show you a few more examples. So I have, for example, like this. So now look at this example now. So same thing, okay? So same thing. But here in this case, what I'm doing is, instead of passing 1:3 as my integer, now I'm passing exact the name of my columns. I'm passing TWO till FOUR. This is exactly I did, right? So this is my first index and this is my 3rd index. So I'm passing TWO and FOUR, right? But my the row indexes still remain the same, 1:3, right? Now I'm passing the same thing on top of my lock. Not, see, this is ilock and this is lock, okay? So now if I do it on lock, see the difference in my output, right? Same thing if I see here in the ilock, the bth component, like the second component of my range gets excluded, while in the lock it gets the both of them are included, right? So till the 1 and 3 both are included here. So that's the difference in my lock and ilock, okay? And also I'll give you a few more examples just to be very sure of. So we can also specify multiple things. So instead of giving a range, I can also give a particular index value. So for example, I just need the 0th and the 2nd index of my rows. So this is for my rows, right? and after this comma I have the columns. I want the first and the third column, so I can also directly give the row indexes and the column indexes, pretty much fine. So I can pinpoint, okay, I just need the 0th index and the second index, and I need only the first index column, which is TWO, and the third index column, which is FOUR, right? I can pretty much do that, so it's still pretty much fine. Okay, so I have this one for iLock, still possible. I can do it for lock also, same thing. So I'm just giving you the same example here. So same thing also possible. So instead of giving this 1 and 3 as my indexes, I can rather specify the name of my columns, TWO and FOUR. So now you can ask me this question. So what is the difference in that case? So because ultimately the outputs are the same, right? So either I give the indexes 1 or 3, or I give the name 2 or 4. So what is the difference here? Why do we have two things here? Okay. So just to give you an explanation here in this case, for example, I have a very big data frame, right? In some of the cases, we might not know the indexes, rather we just know the column names, okay? So it's always easier in that sense that we pass the column names. But again, in some data frames, we might not know the column names, but we know the indexes of it, right? So we just know the column indexes. So so that is the reason why both the options are pretty much possible. So depending on your data, depending on your usage, you can use either of them. It's not like, you can only use one thing or not use a second thing. So it depends totally on how you do the things, how you require the details. Okay. Pretty much fine. Again, this is again the same thing. So one more example here. So I have so this is what it says. So we can also pass the mix match of things. So here we are passing the pinpointed indexes, but in this case we are passing the list of indexes and also the range. So one is my list of indexes and the second is my range of values. Still possible. So I only want 0 and the 3 indexes for rows, and but for the columns I want 1 till 3, right? So again, it's pretty much fine. So it's pretty clear. So in this case, if I pass 1 is to 3, that means that the third index will get removed. So I won't have FOUR column here. I only will have TW and THREE, and for the rows I'll be having 0 in the third indexes. Pretty much fine here, right? So this is what we have in terms of iLock. Okay, and the same thing on lock also possible, same examples. I'm not explaining it again. So lock here in this case, obviously, so all the 3 will be printed here, and only the column, only the rows 0 and 3 will be getting printed. Okay, cool. So now let me give you the last way of creating the lock and iLock. So here we can pretty much do the indexing in terms of filters as well. Okay, so we can write a logic. So DataFrame is very flexible. Okay, it is very flexible. We can write a direct filter logic depending on the values also. Okay, so let me give you this data first and explain you what exactly I'm trying to do. Okay, so now this is my data frame. Okay, this is my data frame. And now what my objective is, I only want the column 3 and 4 where the values of the column 2 is more than 20, right? So I want the wherever the rows, wherever the in the column 2, wherever the value is more than 20, so which is like 30 and 40, right? So indexes are 2 and 3. So I want for these indexes the data for 3 and 4. Okay, you got it? So I want the data for column 3 and 4. So I need the data for 3 and 4, but only for those rows where the column 2 is having the value more than 20, which is 30 and 40. So ultimately I want 303,000 and 404,000. This is what I want the data to be printed, right? This is the question. So now in this case, so we have again two things, rows and the columns, right? So here in the row, I can specify directly the filter logic. So where my row indexes are, where I exactly want the rows to be. Okay. So in this case, I have, just give me a minute, guys. Right. So this is where I'll be having the logic of filter in terms of my data. Okay. So for the row indexes, and for the column indexes, this is where I'll be having the column data. Okay. Gate खोल दीजिए. Cool. So this is what we have for the row logic and the column logic. Okay. Clear? Any questions in this, guys? Anybody is having any questions in this? Is lock and iLock logic clear to you guys? Filter logic, is it clear? Any questions, guys? Anybody? Cool. Great. So this is making sense to you, right? Wonderful. Okay. So let's proceed and let's try to see other parts in terms of so what will we have here. So this is pretty much done. Now likewise I can also do so other filter logics, so we can also specify three where the third column value is less than 300. I want the data for the column 1 and 4 to be printed. So again, pretty much possible, so I can do that. So this is what we have in terms of lock here. Okay, cool, great. So pretty much fine. Cool. So I'm proceeding to the next topic, which is ways to access the columns. Okay, so again, ways to access the columns. This is also very much important. In fact, no, I think we have already covered this topic. Rather, we'll go with this. So Pandas DataFrame Computation. So let's proceed with this topic, Pandas DataFrame Computations. Okay. So in the data frame computations, we have many things. So we have the columns. So we can add the column, we can delete the columns, and even with the columns, what are the different ways we can create the columns by using one topic, by using the existing data, by using external data, right? So multiple ways. So we'll see all of those examples now. Okay. So now again, I'm creating a new same data frame. So I'll just print this. Just give me a minute. So I'll print this data frame here. So I have the same data frame, so 1, 2, 3, and 4, and the data is pretty much mentioned here. Now on top of this, I'm trying to create a new column 5. Okay, so FIVE. I'm trying to create a new column 5. Now in this 5, I'm passing a new set of data. So I'm passing new set of data, which is 150, 250, 350, 450. So another set of information which I'm passing. So I'm creating a new column FIVE5, where the information is pretty much in terms of the external data which I'm passing, the external series of data which I'm passing, right? So 150, 250, 350, and 450. So if I do it like this, now pretty much, so I have my fifth column created, FIVE. Okay, so I have my fifth column created, FIVE here. So here we have the data 150, 250, 350, and 450. Okay, so this is what the data would be pretty much available in terms of the new column. So new column addition is also very easy in that sense. So I can add a new column FIVE, and in this sense we have the data added 150, 250, 350, and 450. So we can have this new column added. Likewise, I can also add another column 6, and this time this column 6 need not to be a number. So here by default we can see that. So all the columns, all the elements of my columns are a number, right? So 1, 2, 3, 4, 10, 20, 30, 40. So all of my data points are number. But again, in this sense, if I want to have in terms of so if I want to create another column 6, right? So SIX as 6. So in this sense, it is not mandatory that I need to have in form of a number. I can still have in terms of my actual strings as well. So I can add this in form of strings also. So I can do that. So if I do it like this, df of 6. Now here in this case, we can also add another column SIX, and which is in this case A, B, C, and D. Okay, so I can have this column A, B, C, and D. Pretty much still possible. Okay. So this is also pretty much fine, guys. Any questions? So we are creating the new column. So we are pretty much creating the new columns 5, FIVE, and SIS6, 2 columns, and with the additional data the way we wanted to create it. Okay, so we can add it either in terms of number, or we can either add in terms of strings or characters as well. Pretty much fine. Okay. So this is one way to add the additional column on top of my data frame. So by using the simple assigning operator, so we add the name of my column here. So just like additional by giving the square brackets, and we write the name of the column, it gets pretty much added, right? Another way is and rather using the external data, we can also use the internal data. Okay, so here in this case, suppose I have 7, S-E-V-E-N as 7. I'm going to create a new column S-E-V-E-N in this case, where it is a multiple of 1 and 2. So here in this case, so I have 1 and 2 column here, right? So I want to create another column which is a multiple of these two. That means that 10 cross 1, 20 cross 20, 20 cross 2, 30 cross 3, 40 cross 4. So this is what I want to create the elements as, right? I can also do that, but it's pretty much fine. So what I can do is, in this case, I can simply write df of 7, which is like SEVEN, and at this time, instead of passing an external data, I can simply do df of 1 multiplied by df of 2, right? So ONE multiplied by df of TWO, right? So I can pretty much do that, which is also very much fine. Okay, so this is what I have. So I can do it either by passing an external element, either by passing an external data point here, or I can also use the existing column data, and then I can create it using the external internal available data frame, internal available columns as well. Both the ways are pretty much fine in terms of creating the columns. Okay, clear, guys? Cool. So proceeding with the next topic, which is column deletion. Okay, so now I have created the column. So I have pretty much created the column. So I have all the new columns created. So now one. So the original DF now. Okay, so now this original DF is pretty much modified now. Okay. So initially I had 4 columns, 1, 2, 3, and 4, but now I have 7 columns. So 5, 6, and 7. These 3 additional columns got added in my data frame, right? And how we added? We modified the existing data frame. We added 3 additional columns in this, right? So this is pretty much fine. So now we can also delete this. So we can also delete the columns, and how we can delete the columns? By using the del function, del. Okay, so we can delete. So for example, if I do del and df of 6 six. So if I use a del function on top of my data frame six, I can delete this, and also I can use the other thing pop. Okay. So now, for example, look at the difference here. So if I do it like this. So using a del operator, del, and then I can pass the column name SIX. So in this case, you can see the SIX is gone. Okay, so I have 5 and 7 here, but SIX is gone. And also I can do df.pop. So df.pop is also done, and then I can see df.pop. Df is 7, 7 and 7 is also gone. So what here, df.pop also shows what exactly column the data which is getting popped out. So it is also giving you an output here, right? So the data is 10, 40. 90 and 160. These are my 4 indexes which is getting deleted. So this is what it also prints you. Okay. So this is what. So 2 ways of deleting the columns, by using a del operator or by using a pop operator. So both of them are equally fine. So we can pretty much do that. Okay. Okay. So now another very interesting topic which we have in DataFrame is addition of rows. Okay, so that is my append operator. So how does the data append works? So we have also seen append in my list. We have seen append in my series also. Likewise, we have pretty much append available in DataFrames as well. Okay, so we have pretty much append available in DataFrame as well. So how does append works in DataFrame? So in this case, I have my df1. So df1 is nothing but my pd.dataframe, all the different elements here, 1, 2, 3, 4, and we are giving the column names as A and B here. Okay. So now in this case, this is my DataFrame 1. So df1. So this is what I have in DataFrame 1. Okay. So I have A and B here, and I have the column indexes 0 and 1. So this is my data. So 1 and 2 will be my first row. 1 and 2 will be my first row. And then 3 and 4 will be my second row. So 3 and 4 would be my second row here, right? So this is what I have in terms of my column headers A and B. Okay. So first row 1 and 2, and the second row 3 and 4. Okay. Now if I'm passing this element on top of my this, so this is my df1, and now I'm creating another data frame df2. So in this case, data frame 2, I'm using the same header A and B. Okay. And in this case, I'm passing the data 5, 6, and 7 and 8. So I'm passing 4 different elements here. So different data here, but the column headers are pretty much the same. Okay. So now what I want to do is I want to add. So I want to create a new data frame df3 where all the elements of my df1 is appended on top of my df2, right? So now in this case, what I'm saying is df2 basically is getting appended on top of my df1. So in this df3, I'll not be having I'll not be having 2 different indexes. I'll be having 4 indexes here. So now look at this. So first let me remove this part and show it to you. So now can you see this? in this df3, once I've appended df1 with df2, right? So I have 1, 2, 3, and 4, and then I have 5, 6, and then I have 7 and 8, right? But here, as always, it's similar to my series also. My indexes are wrong, right? So you can see this. So I have my indexes as 0, 1, 0, 1, and again 0, 1, and 0, 1. So same indexes for two different data frames got added up, right? So same indexes as likewise. So 0, 1, 0, 1, and likewise we have the indexes got added up, right? Now, definitely, since this indexing is wrong, right? So we definitely know that this indexing is wrong. So because we have ambiguity in this, so the same index which is 0 is getting referred to two different rows, right? So which is wrong, which is incorrect. So in this case, we have this functionality reset index. So if we do reset index, definitely we're going to reset the index. And inside this drop true, I'll show you what will happen if I won't give the drop true for now. So now in this case, I simply pass dot reset index. So in this case, what happens is, there is another column called index got created, and the original indexing, which was 0, 1, 0, 1, got saved, right? So I have another column got created index, and in this case the original indexing 0, 1, 0, 1 got saved here. Okay, now if I don't want to keep the original indexing, so in this case I can simply write the argument drop is equal to true inside my reset index function. So in this case, even the original indexing is getting dropped, so I am not saving the original indexing. Okay, pretty much the logic of append, how exactly it works. Cool. So again, we're gonna take one more function today, which is drop. So how exactly drop works. So likewise in del or pop, what we studied, we have similar called as drop. Okay, but in drop, it's not only for columns. We can also drop the rows here in this case. So we have an argument called as axis. So axis is equal to 0 means we're going to run the operation on row wise operation. Or if you're going to give axis is equal to 1, that means that I'm running the operation column wise. Okay, so that is the only difference I have. So for example, if I give df.drop, okay, and in this drop I'm passing the list of elements which I want to drop. So I'm passing here 1 and 3. That means the column names which I'm passing, and also I have to specify the axis. Here the axis is 1, right? So in this case, it's going to drop the axis 1 and 3 here, right? So you can see this. Now 1 and 3 got dropped, and I have 2, 4, and 5 only left here, right? Cool. Also, but you can see this, so this is the output here, right? But what if I call the df again? So if I call the df, it's still having my 5 columns, right? You can see this, it is still having my 5 columns. The original 5 columns is still retained. The reason is, although we have run this, but it is not saving the same data in the data frame here. So it is not saving it here, right? So what I have to do in this case, I have to save the data again in the data frame. So how I have to do is, I have to do it like this. So I have to assign this, run the same information, for example, like this. If I do it like this now, so now in this case, my df got altered. Okay, so now my df got altered, and in this case, the data frame will get changed. And now if I print df frame, so now my df will have only 2, 4, and 5. Now original data frame got changed. Okay, pretty much we have. So we can also do different multiple things. So we can also specify the indexes like A and B here, and we can specify A and B. So that is my the column names, and then whatever I want. So okay, also if I don't want to give the axis equal to 1, we have also argument called as columns. So we can also specify directly the columns is equal to this. So you can see inside this drop, I have multiple arguments. You can see this. So I have something called as columns as well. So I can directly pass the columns also. Okay. So if I pass the columns, then in that case, I don't need to specify the axis because it is by default meaning the column itself, right? And also we have a very good argument called as true. So if I write true here, in this case, the assignment is not needed. So in this case, this is not needed. So we are making sure that whatever the output of this, it is getting replaced into my original df. Okay, so this is what it means. So in place is equal to true. This is what it means. Cool, guys. This is pretty much it. So I think we have covered quite good amount of topic today in terms of data frame. Any questions, guys? Anything which you want me to cover, which you are not able to understand? Anything? So we covered data frames, how we create the data frames. We saw multiple ways to create a data frame using list of dictionaries, and also we use different other ways to create the data frames, right? And also we understood how to add the columns, multiple ways we saw how to add the columns and delete the columns and all of these operations as well, right? So pretty much what we wanted to cover today. Great guys. So with this, we can take a pause, and then I think we can again join back tomorrow, same time, 10 p.m. Okay. So and then we're gonna cover the rest of the topics in DataFrame. In fact, as soon as we finish the topics in DataFrame, we're gonna do some good questions as well. So please stay tuned. Okay. Great. So guys, thank you so much for joining us. And if there is no questions, so I think we can pretty much close. So see you tomorrow again, same time, 10 p.m. and we're gonna cover some of the great pandas functions tomorrow. Okay. And we'll try to do some more exercises as well. Great guys. Thank you so much and see you tomorrow. Till then, happy learning. Bye bye.